Hello everyone, thanks for watching my video. In this video I'm gonna show you how you can make simple robots and also connect your robot to your smartphone. Actually I made this video in another language that wasn't English, so I tried to record new voice and then I tried to mix my voice with the video, so maybe the sound and image aren't coordinated, so sorry for that. Actually, what you want to know about this video, actually, at the first we try to write a program in Android, and then we try to design a circuit, and finally we will connect our robots and that circuit that we made. We connected them together. We connect our robots to our mobile phone. So you can expand your knowledge based on this video, and you can implement your program on iOS also. And what we need to know, actually, we want to send the data via USB, and then we try to convert our data from USB to serial, and finally we send our data that converted to serial to our robots, and our robots will be based on AVR microcontroller. So try to use a mobile phone that's able to send data via USB. So basically, it's better to use a mobile phone that support Android 4 or higher version. And as we know, currently most of mobile phone are actually have uh, higher Android version, maybe 8, 9, and higher. So let's start a new project in Android Studio. I try to make a simple project uh, with minimum Android API 14, and we try to make an empty application, and we just press the button next, next, and finish. We don't need to change anything else. So at this time, just wait to uh, because Gradle going to finish, actually need to build, and we just need to wait until Gradle will finish. Perfect. So when your project building finish, try to add the library. This library help you to send the data via USB. You should to type compile com dot github dot felhr85, and this library is for USB serial converter. The version that I used at this time is 4.5, and to get this library you need to write, you need to actually provide a URL, so that it's help the Android Studio to find your library. So library is in this address jetpack.io, and then try to press the sync button, and after that we will ready to write or program. So just add this file. You can find this file in my GitHub website. I will actually link this file in the comments. You can find it below this video. So just add this file to your project, and you will see this file is implements to transfer data between USB ports. So first of all, we need to actually define the variable that kind of a USB config. I name it USB config, and then I try to give it a value USB conf equal new USB conf this. So with this variable, we're able to send the data. So we can easily send our data, but first of all, remember to add a permission for USB port. So we need to add a tag in our manifest, uses feature Android name, android.hardware.usb. So because our mobile phone is a host, and it's the host is able to send the data, so add the uses feature USB host in your Android manifest file. The file that I written before that extends with service, it's give you actually give you situation that you can send the data in your program. So definitely we need to add this service in your Android manifest. So we are ready now to send our data. So easily on reason function, we need to start USB config. So this function tells the Android that I need to connect via USB port. So definitely each time you resume your application, you need to run this function. So I try to write another function to send data, but before that, try to pause USB config. So maybe the other application need a USB port. So definitely when you finish your work with your application, you need to pause your USB config. So at this time, I try to design simple layouts that with just a simple press on the button, I'm gonna to send the data via USB port. So I just add the button on the layout, and then I try to define that button with this code button equal find view by ID, and you need to give your ID to your command, and then on the on-click listener, I try to send the data with a simple command USB config that write data help. So at this time I just want to send a simple string to USB data, and later I will back to this code and I will develop this code to do more things. So let's put this code off by now, and we will come back to this code to test our code. At this time, I'm gonna show you how you can implement your robot. So you need these components, you need these electronic components to make your robot. So definitely you can find all these components in eBay or any other online store. So try to make a list and buy these components, and we will make your robots with the help of these components. So the data that we need for our robots, first of all, I use the dot board that board that help you to uh, actually soldering your circuit without any other facilities. You don't need to um, produce a PCB, so you can easily can use this board to implement your robot. So at this time I just use a um, small dot board, and also because you want to if you want to move your robot, so definitely you need a motor. uh, so at this time I just use a motor and gearbox. It's a plastic gearbox, so um, it's easy and easy to find and cheap. So if you want to use any other motor, so it's up to you. um, it's depend on how you want to make your robot. So definitely you can find any other motor or better motor with metal gearbox. So it doesn't matter at this time which motor we use. We just need to learn how we can make a robot. So I just put these motors away, and then it's a main part of our circuits. This is microcontroller. I use micro ATmega 8 for our robot. And if you want to solder your microcontroller, it's not too good solder your microcontroller directly to your board. So it's better to use a socket instead. You have to solder your socket, and then you will put your microcontroller on your circuit. Well, uh, to actually run or motor, we need to send the data from microcontroller to motor. We need the driver, and at this time I use L298 IC. This IC help you to drive your motor. So also we need a circuit for this IC. So as I said before, to send the data from mobile phone, we need a USB to serial cable, and also we need a connector to connect our USB serial to robot. So I bought a 90-degree pin socket for this purpose. Well, to avoid the noises in your circuit, so definitely to make voltage stable in your circuit, definitely you need a capacitor. So at this time I use 220 microfarad capacitor for this purpose. And to connect a USB serial to your microcontroller directly, definitely you need a transistor and a resistor between your connector and your transistor. So we need two different resistor. One is 10 kilo ohm and second is 220 ohm, and the transistor is, as I said, 8050. So this is up to you. If you want to have your robots have an LCD, you can use a character LCD in your circuit. It doesn't matter if you use it or not. I just use it to show you um, the data that will transfer from our mobile phone to a robot. So I just use this as a actually it's not compulsory. You know, you can use it or not. It doesn't matter. And also we need a pin header. Pin header help us to make a circuit and connect everything together. It's a male pin header, and also we need a female pin header to make a connector together easy and cheap. So for actually reduce voltage, if you use adapter or maybe if you use a 9-volt battery, you need to reduce your voltage with this IC. You can reduce this IC help you to reduce and keep your voltage in the same, in a fixed voltage from 9 to 12 volts to 5 volts. So let's begin or design or circuit. All components that I showed you are in this picture. So the IC 7805 is used to reduce the voltage. L293 is to drive a motor. 80 mega 8 is a microcontroller, and LCD 8050 is used to connect the serial port to your microcontroller. So let's begin from the LCD. The first pin from the right should connect to ground, and as you know, the ground is a minus part of each battery. So, and VCC is a plus part of each battery, and we can show them as like a sign that I showed you like this. The second pin should connect to VCC, which means plus part of each battery. And also 14th pin and 15 pins need to connect to VCC and ground as well, same as pin 1 and pin 2, just like that. So what should we do on a microcontroller? The actually 1, 2, 3, 4, 5, 6, 7 pins on your microcontroller should connect to VCC, and the 9th pins should connect to ground. On the driver and regulator, if we faced a regulator up, the first pin should connect to a 9 volt, or you can connect this to your adapter, maybe 12 volt, it's okay. The second pin should connect to ground, and the third pin also is VCC. That means you should connect this pin to all other VCC in your circuit. On your IC driver, you also need to connect two pairs of each side of your RC driver to ground, just like that, and also the first pin and 16 pins need to connect to VCC. The other pin also need to connect to microcontroller and motor, like this, and each part, as you know, each part of this driver is used for separate motor. So I try to connect these pins also to motor. Well, let's do the connection on the serial port. So the third pin of serial port is actually transmitter port, so it's used to transfer the data. So if we want to transfer the data, we need to connect these pins with the transistor to the base pin of our transistor. So we will connect this with the 10 kilo ohm resistor to the base pin of our transistor actually. The fifth pins also need to connect to ground. The collector of your transistor with another resistor should connect to VCC. Other resistor we use is 2.2 kilo ohm. May I mention this resistor before with the wrong value? So the correct value is 2.2 kilo ohm. So just connect this to VCC, and with the same pin you should connect this to RX pin of your microcontroller. RX pin is a pin that receives data. So the transmitter pin connected to receiver pin. With this technique, we implement a TTL method to transfer data from USB to microcontroller. So let's back to the LCD. I used actually a potentiometer to actually setting the LCD contrast. So I connect the transmitter to the third pin, and then I connect the pin the pin B0 of your microcontroller to the fourth pin of your LCD, and we do the same for the other pin, just like that. So we don't need other pin or LCD. We will start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pins on your IC, just like that, your microcontroller. and you just need to leave the other pin on your LCD. You don't need that. So I try to connect the last pin on my LCD to the tenth pin of my microcontroller, just like that. Yeah. All right, we're done with the LCD now, so it's time to connect our driver to the microcontroller. So how we can do this? Actually, the second pin, the seventh pin, 11 pin, and also well, 15 pins should connect to microcontroller. The other pin should connect to motor, just like that. So the pin number 3, 6, and 11 and 14 should connect to motor. The other pin, as I said, should connect to the microcontroller, just like that. So in this case, I connect this pin to the ground, so our motor just drive with a single actually direction. If you want to drive your motor inverse, you should connect that pin that I connected to ground to the microcontroller. So at this time I just connected them to ground. So let's see what happened in real life like this. Each components I designed, I just put them on a paper to show you what exactly happened. This is the Pentansiomet. I try to put them in the right place. This is a connector that get data from serial port. This is our transistor, 8050 transistor, and finally this is our resistor. Yep, just like that. Here we go. This is all we need to know about our circuit. Just like that, simple, you see. Well, uh, actually, as I said before, to make a voltage stable in our circuit, we need to use a capacitor. So definitely we use a capacitor, and we just need to connect our capacitor each pin to the right actually voltage. Try to solder your capacitor as close as you can to your microcontroller in your circuit. So let's begin the soldering our board. I try to put the socket, microcontroller sockets on the center of my dot board, and then I just try to just try soldering my socket pins to the dot board just like that. Okay, so to connect the LCD to the board we need the pin header. I just try to cut the pin header. Each character LCD has 16 pins, so I try to put the LCD there. I try soldering them just like that. Just be careful, you need to connect the middle pin of your potentiometer to the third pin of your LCD. So to connect them, do like I do. To connect each part of your dot board, when you soldering each dot actually, just wait for a sec to make that part cool and then try to connect each part together. When you solder each part, just leave them for a sec to make them cool, and then back to them to soldering them later when they became cool. So I did all connector just like I draw that circuit before for you. So you see your final board will become just like this. You see, I try to use the round board for the ground, so I don't need to connect each ground part together, so it's easy to connect the ground to the round part of your board. And I try to connect my battery with this connector, and the minus part of battery that's the same as ground is connected to ground. And also for VCC part, as I said, all VCC should connect it together. I try to connect all VCC to the same route. As you can see, this part is all VCC route that connect it all together. And also to connect our serial circuits to our microcontroller, I use two resistors, one transistor, and I try to solder the capacitor right after microcontroller. Also, I just use another capacitor just for sure. It's not compulsory. Just for sure, I just solder that on the actually another part of my board. The other actually the other components are connected like draw on the paper before. Just to put them pins away, because it's helped me to route that actually that route via this part. So finally I try to keep my microcontroller on this circuit. Yeah, that's it. Now I can connect my USB serial to that circuit, and I can send the data from mobile to my microcontroller just like that. So now we need to program or microcontroller with the help of CodeVision AVR. So definitely if you use a STM32, you can use any other ID, but at this time I use CodeVision AVR to program my AVR. So to make a new project in CodeVision AVR, just select the new and try to make a project instead, not a source, a project instead, and press the button, and at this time just press yes, because Code Wizard help you to make your project easier. Done. So at this time just select your microcontroller type. So our microcontroller is 80 mega, so I just keep it all away, and just I try to push the button OK, and then at this time, because my microcontroller is 80 mega 8, I use 80 mega 8 in this part. So the clock, actually the timer on each microcontroller as a standard should 8 megahertz. So I just leave it here without any change, and then I try to back to port, because I need to make a port that connected to driver as output. So the port that I connected before to driver should be config as output. And I also, because I connected the LCD, character LCD to the microcontroller, my character LCD is 16 pin, so I just config that pin that I connected before to the microcontroller like that. And also I need to make a receiver active in my microcontroller, because I want to receive a data from a serial port. Just leave the other settings, you don't need to change them. And finally try to generate your program. Done. When you generate your program in CodeVision, just right after the main function, try to define a variable with a kind of character. At this time I use 5 character, because I want to send the hello world, and hello world already has 5 character. So at the end of your code, just write after that place dimension, place your code here. Just with the function gets, you easily can receive the data from serial port, and the serial pin actually that I mentioned, that was RX pin. So when I receive that data, I locate a place on LCD and I try to show the string on the LCD. So how I can build my project and how I can transfer my project on my microcontroller. So when you compile your project, try to um, connect your programmer, chipset programmer that's help you to program your microcontroller with that. Try to connect your programmer and try to put your microcontroller and your programmer. After program that found your microcontroller is connected, try to locate the file with the hex extension. Try to select them and try to program the uh, actually the program that you wrote before. Just be careful this config is set before and try to program your microcontroller just like that. Done. When you finish your programming, as you can see on the board, I use my programmer to program my microcontroller. I show you how you programmed my microcontroller just like that, and then I try to transfer that program I wrote on my microcontroller. So now I put it on the board. I try to turn my circuit on and I try to push the button that I wrote before, and as you can see a hello word on your LCD just like that. So excited, isn't it? So it's time to write down the program that we need for a robot. So I tried just to design a layout to control my robot with that. I try to design a layout with 4 different buttons. One for up, one for left, one for right. And I'm sorry because as I said, I made this video in another language, so at this time I try to translate what I said before in English, so sorry if it's not that qualified that you expect before. And as you can see, the word that I wrote here is in Persian, so it's actually each button mean up, left, right, and stop. So I try to define each button, and I try to set a listener for each button, and I try to send a data when I pressed each button, just like that. So each button should um, actually have different um, code. So I try to send a U for button up. I try to send L for button left, and I try to send R for button right. And finally, I try to send character S for button stop. Done. So let's see what exactly happened. You can see when I try to send the data, finally I can send my data to my robot just like that. And this is what exactly you can make. Very cheap, very easy, with a few electronic components. I hope you enjoyed my video. See you guys in my next video.